Hello viewer and welcome to the e-learning classroom. So today we want to look at this setup here that is on Boyle's law, touching on pressure against the volume. So we have some trapped hair, we have mercury index, and then we are given the length of the trapped hair, that is centimeters, then the height of mercury 5 centimeters. We are also given the second setup where the height of mercury is still 5, but now we are trying to find the length of the air column when the open hand is facing upward. We are given the atmospheric pressure is 76 centimeters of mercury. That is the normal atmospheric pressure. Then we are trying to find this height here and also this height here when the open hand is facing down. So first of all, it's important to know that if you're working with a barometer, let's say we have some mercury in the barometer, which is used to measure the atmospheric pressure. So this height from here, this height here is normally given as pressure. That height there is given as pressure. For example, you can say 30 centimeters of mercury, 40 centimeters of mercury, and so on and so on. That is when you work with a barometer. So viewers, now that we realize that the height of the mercury in the barometer is given as a unit of pressure, that's why we have a unit called centimeters of mercury, and we also have millimeters of mercury. So in that case, we are saying this height of mercury can also be taken to be the pressure. That's why we are also given in centimeters of mercury. So it's important to ask yourself, what is making this mercury index not to get in once or not to come out once? So that means there is a pressure acting, there's a pressure balance which is taking place, because you should ask yourself, suppose you hit this hair here, if you are hitting this hair, it means this hair would expand and the level of mercury, this mercury index would come out once. And also if you cool this hair, it means this mercury index will come in once. So in that case, we are saying, if you look at this setup, the mercury index is neither coming in or coming out, and that means there is a pressure balance. So for that case, the pressure acting to balance the level of bead on this side is Pg, that is the pressure of the trapped gas, and the pressure acting from the outside is atmospheric. So, and that means the Pg is equal to the atmospheric. For this case, Pg is equals to atmospheric. Maybe we can also write it here. Pg is equals to atmospheric pressure. Remember, we are dealing with gas laws, so our interest is the pressure of the trapped gas. Let's come to the second setup here. This index is neither coming in or coming out, meaning there's a pressure balance. And the pressure supporting it inwards is the pressure of the trapped gas. That is the pressure that is supporting it from falling inwards. Then the pressure acting downwards, first of all, we have the atmospheric. Every open hand must have atmospheric. We also have this liquid here, which has some weight. And the weight is contributing to some pressure, because we know pressure is force over area, which can also be weight over area. So for that case, we have some other pressure here, which we can call PL. Pressure due to the weight of the liquid can also be given by H rho G. So that means Pg is equal to PA plus PL. In other words, pressure of the trapped gas here is balancing the liquid pressure together with the atmospheric pressure, because you are saying if you are hitting this here trapped here, the bead would come out once. So we also have this other setup here. Maybe we can look at the summary. The pressure acting towards the lower side, first of all we have PG, the pressure of the trapped gas. The weight of the liquid is also acting downwards, so we also have PL, pressure due to the liquid, and upwards we have atmospheric, PA, and that means PG plus PL is equals PA. In other words, pressure of the gas plus pressure due to the liquid, which are all acting towards the lower side, is equal to the atmospheric, which is acting on the upper side. And that means, because our interest is PG is equal to PA minus PL. In other words, atmospheric pressure is pressure due to the gas is given by atmospheric pressure minus pressure due to the liquid. So let's see how now we get this height 1. So since we are relating pressure and volume, it is right to say pressure 1 volume 1 is equal to pressure 2 volume 2. We are relating A and B. Pressure 1, which is the pressure of this gas, trapped gas, times its volume, is equals the new pressure of the trapped gas times its new volume. So pressure 1 is PG, which is because we don't have PG and we know PG is equals to atmospheric, so we just write 76 centimeters of mercury. Volume 1 is the height. We take the height to be the volume, so that is centimeters. Then pressure 2 is the pressure acting on this gas here, which we don't have, but we know it is equal to atmospheric plus PL. So atmospheric is 76 plus PL, pressure due to this liquid, which is 5 centimeters of mercury. Because if you look at this one here, we have 5 centimeters of mercury. Remember, we are saying height of mercury is also a unit of pressure. So that is pressure 2, then into bracket times volume 2. So with that, volume 2 becomes, so let's see that now. We have 76 times 30, we get the answer, then divided by 81. If we divide by 81, so volume 2 becomes 28.15 centimeters. That is the new height. In other words, height 1 is equals 28.15 centimeters, because you are taking the height to be the volume. So that is how we get this height here. If you look, 28 is less than 30. That means when it is facing up, open hand is facing up, the height becomes less. Let's look at number C now. We are comparing C and A. So we still know pressure 1 volume 1 is equal to pressure 2 volume 2. So pressure 1, we still have here pressure of the gas, which is equal to atmospheric, 76. Volume 1, we have it here, 30. We are comparing A and C. Then pressure 2, the pressure of the trapped gas here, which we do not have, but we know pressure of the trapped gas is equal to atmospheric minus pressure due to the liquid. So it means 76 minus 5. 76 minus 5 times volume 2. So let's see, volume 2 becomes what? Volume 2 becomes what? Let's see there. 76 times 30. We'll get the answer. Then divided by 71. This one is 32.11 centimeters. In other words, height 2 is 32.11 centimeter. That is the new height of the trapped gas. Remember, we are working with the Boyle's law, and that is how you solve this question. Remember, it is a very, very testable question, dear viewers. The key thing to note is that when the open end is facing up, the pressure of the gas, you had the atmospheric and the pressure due to the liquid. When it is the open end is facing down, pressure due to the trapped gas, you subtract atmospheric minus pressure due to the liquid, and if it is horizontal, pressure due to the gas is simply the atmospheric. And we are also taking the height to be the volume. So that marks the end of today's session. I wish you all the best.